Okay, so in this video session, I'm going to explain what exactly the project I've been working on. Okay, so this is basically Apex Trade Engine. This is like a very small project, but a very complex project. The goal of this entire project was to, you know, work something other than a simple crude operation. So basically, I created this application to simulate a finance trading platform where millions of transaction happens in a minute, and what kind of mechanism are being worked on behind the scene. So to fast track, okay, any complex web application or platform that has high throughput and low latency, okay, is on some level is working on microservices. So basically, I created microservices with the help of Spring Boot and Kafka and some Docker services to help this achieve my goal. And if you see my screen right now, in this screen, we have several modules, or should I say, microservices, which are integrated with each other, interlinked with each other using Kafka. We have Docker Compose file, okay, and this Docker Compose file, I've configured Postgres. This entire application is uh, stateful application, and the data is hosted on Postgres. Kafka for messaging queue, and Zapkin for monitoring the network request. So if I have two options, either I'll just say Docker compose up. What it will do, it will create or will execute the Docker command where it will initialize all the services configured in this Docker file. So if I go and open, as you can see, we have three services, three processes going on. One is Zapkin, one is Kafka, and one is Postgres. Okay, so I'll just close it because I prefer to run it in the background. So I will just click on this. This also works the same way. Oh, it's anyways. So to run this project, first I have to run the command clean install. What it does, it basically builds all the modules or microservices within the project. And secondly, as it is building, the reason why I chose VS Code instead of IntelliJ is because IntelliJ already gives you a scaffolded project, and my goal was to understand Spring Boot from its core level, okay, deep, how everything is configured, how everything is, uh, you know, uh, put the puzzle into big picture. So it's very easy, okay, to build your own project from scratch rather than asking IntelliJ to scaffold the project. Uh, So everything boils down to this POM XML file. Okay, in this POM XML file, you structure your PML file with some prerequisite tags like model version, okay, parent tag, group ID, artifact ID, version, package, and module. This is parent form, so this we have to mention all the child module here as well. As you can see that I've mentioned API gateway, auth service, Eureka, common DTU, and so on and so forth, and some general dependencies that are being used throughout the whole solution. Okay, so on and so forth. So basically, when you add this pom.xml file within a folder, okay, and when you run mvn clean install, it basically builds all the project, okay, download all the dependency, put it in the jar file, and yeah, okay. So I'll explain you what these modules are. Basically, if I open up the architecture file somewhere, it was somewhere. Okay, I'll just open the, yeah. Okay, if I open this architecture diagram, so basically what is happening is that I'll explain the life cycle. In this, where Eureka server is independently executed, run independently, and the purpose of this service is to, keep all the microservices in check, because in practical, okay, there are like numbers of microservices, like some 20, 25, or even more than that. So keep manually checking if all the microservices are working fine and this and that. This is very headache. So Eureka, what the purpose of Eureka is it gives you a platform, uncentralized platform, and it connects or gives you the health check of all the microservices which are working, which are not. Okay, so that's the purpose of Eureka server. Secondly, it, there's another service called API gateway. So basically, it's a centralized tunnel or centralized gate, okay, that connects all the other services. Because what happens is that these microservices are basically web applications, okay, that are dedicated to specific tasks, and all these web services have their own port, okay, and own DNS server URL. So it will be very hard to manage all this. So what API gateway does is it basically forwards or proxy forward those requests and become the man in the middle. Okay. Then we have Kafka. Kafka is again is a messaging queue. It's basically responsible to have communication within the services. We have Postgres, where we are saving all the applications data. In this, we have three major schemas, auth schemas, where we are saving users' data. Order schema, all the new orders, trades are being saved here, and the user's wallet. And in that, we have Prometheus and Grafana and Zapkin. These are basically observability and monitoring tools to check your requests and the complete life cycle. So if I'll run this project, mvn spring boot run, and it will run all the services. Hmm. Okay, I'll just skip that part. I'll just run it like that. First I run API gateway. It's loading. Second service, auth service. Common DTO is not a web project, so I will skip that. Eureka service, matching service, order service, and wallet service. And as the name suggests, the responsibilities of the services are very obvious. Auth service is basically responsible to create new user and log in new user. Uh, Matching service is a service that is responsible to match the buyer and the seller, okay, and execute the trading operation. Order service is responsible for creating new orders placed by users. Wallet service is basically like users' own wallet, okay, and API gateway is connecting all these services to come together. So if I open Eureka server and if I'll refresh, okay, so this is basically the local hosted with this port. This is a Eureka server. So as you can see, it's mentioning that one, two, three basic services and one API gateway service is working. Okay, and if I'll open and one of that, it will give you the basic state of what kind of technology and everything is working behind the scene and where it is hosted. You can also check the health, okay, in case if you want to check it by any means, okay. And yeah, here comes the Eureka part. So I'll demonstrate you the application, like working application using Postman. I've already added this Postman collection in the GitHub repository. You can continue from there as well. So I'll start with the user. I already have uh, created some basic users. We can also create a new we can also register a new user. Okay. So when I click on send, okay, what it does, it basically does the confirmation authentication from JWT token, and it returns the token, and it by default set it to environment variable. Okay, so we don't have to manually copy paste it everywhere. So after that, I will place an order. Okay, oh, before placing order, I will just check how much balance do I have. Okay, so for that, I will check, I will put the username here. Okay, so as you can see, this account has 120K USD and 0.7 Bitcoin. Okay, so if I'll place the order, let's suppose if I place the order, okay, so in return, it will give me order ID. Okay, and in this scenario, what is happening is that this user, Mazhar Hamid, is basically trying to sell his Bitcoin, okay, with a price of 40,000, and the Bitcoin quantity is zero point 0.5. So basically, he wants to sell his zero point 0.5 Bitcoin with the price of 40,000. Okay. So what happens is that this is the sell scenario. Okay, it can uh, happen in any way, vice versa. Anyone can buy first and sell later, and someone can sell later, or someone can sell first or buy later. What happens in that is that basically in the matching engine, okay, this is the core of this entire infrastructure. So what happens is basically we create mm, we have created a tree map structure. Okay, it's very fast and it's very how should I say that? It doesn't take that much space. Okay, and it's fast retrieval because it's a tree map. And this tree map is basically segregated by the price. Okay, so if you I mean if you know the tree map structure, okay, so this is basically log n in time complexity. So whatever, like, if I'm buying, okay, if I'm selling, sorry, if I'm selling, so that record will go into this variable in this memory heap. Or if I'm selling, sorry, if I'm selling, so it will go into this heap. And if I'm buying, it will go into this heap. Okay, anyways, vice versa, what happens is that every time an order comes, okay, it goes to either it checks the scenario if it is buy scenario or sell scenario. Okay, so whatever the case is, it basically checks. And then I'm not sure if the time is very less because it was supposed to be 2 or 3 minutes, but I cannot explain everything in detail. So basically, what happens is that right now I've made the request for sell, okay, and now it is stored here. Okay, so what happens is that when I click on buy, or before that, I can also show you the trade API, my order. Okay, yeah, my order. Okay, so yeah, there it is. Yeah, there it is. Okay, so Mother Hamid has placed the order, and as you can see, it's clearly visible here. And if I log in with different user, and then place the order by this user. Okay, now this user, White Said one, he comes and he says that I'm willing to buy a Bitcoin, okay, zero point 0.5 Bitcoin worth of 40,000. So what happens is that since these two orders have been placed separately, asynchronously through different time and different region and different location, it comes down to the matching service engine. Okay, and matching service, what it does, it first checks the trading symbol, because right now I have already only configured from Bitcoin to USD and USD to Bitcoin, but it could have been different crypto trading or different fiat currency. So based on that, we classify or we create segmentation, and then we do the processing. So basically, it's like a room. Okay, different symbols have different room, and different room have sub uh, pricing, you can say. So it's a pool basically. Okay, so from the pool, the system basically uh, um, tries to find the best matching. Okay, and then it triggers the trading event. Okay, if it is successfully matched. If it is not, so it keeps in the heap. Like for example, right now, if I make the trade now, so as you can see, since the trade was successful, okay, so it found the match, so it will trigger a Kafka event. And what does Kafka event does? It basically goes to the wallet event, okay, and it closed the deal. So if I show you the wallet, okay, so the wallet, if you see, before it was zero point 0.7, now it is zero point 0.2, and the amount, USD amount, has increased because from Mazhar Hamid's perspective, he sold his Bitcoin worth of zero point 0.5, okay, which is reduced now, and he got his uh, even though it was the pricing was 40,000, but since the Bitcoin was half the quantity, so basically the price, actual price was 20,000. So 20,000 got deposited in his wallet. Same goes if I check with Wahid Said one's wallet, he got his Bitcoin increased and USD decreased. Okay, so this is pretty much going on. I would suggest, since this video has a very short time request, 3 or 4, and I think it's already done. So all the instructions are very clear, and everything is already in the repository. Okay, I hope you like this project because I learned a lot, especially Almax. I didn't have the time to explain the Almax, what it basically is. It's a basically very powerful engine to handle millions of requests per second. Uh, Even though I cannot like demonstrate here because I have local, okay, everything set up is local, but the point was to understand and implement it. So this Lmax is basically a disruptor. Even like I like this so much that I created a side project on this. Where did it go? So basically, it's a ring buffer, okay, that saves the request, incoming request, into pre-allocated slot, okay, so that garbage collection or any low-level activity doesn't have to be performed, because to be very like it's like even the slightest computation can get accumulated and exponentially grow if the activity or response or request that is coming is in millions. Okay, like for example, like even like for example, one request is consist of 1 KB. Okay, and all of a sudden there is a burst of millions of record per second. So do you think that memory buffer or typical cache or anything can handle it? No, it will not give a proper throughput, or you have to scale it, which is again very time consuming and latency, full of latency. So this mechanism is basically being used, and it was introduced by Almax. Okay, this is basically a financial institute. Uh, yeah, HFT it's called. So yeah, again, I don't, as it was instructed that I have to create 2 or 3 minutes or 4 minutes video. So I think it's already done.